and welcome to Math World. Today we're going to talk about volume formulas for 3D figures. Alright, so volume is just the measurement of the amount of space inside of an object, okay? So we're going to look at three different figures here, the cylinder, the cone, and the sphere, and see if we can figure out what's inside of the cylinder. Cylinder is most commonly if you see like a can of something, like maybe a can of green beans or maybe a can of paint. How much paint would be inside of this cylinder can is what volume is, how much is inside of it. All right, and now all of these figures are going to have basic formulas that you don't even have to memorize. We always give you the formulas. They're easy to look up or Google, so you just have to know how to use them. All right, so let's start with the cylinder. In order to calculate the volume, which I'll be saying is V, for any cylinder, you only have to know what the radius and height of the cylinder is. So the height would be, this kind of side of the can. We're going to call that the height. And you also have to know the radius. And the radius is going to be half of the distance across the top of the can, or top of the cylinder. Try not to get radius mixed up with diameter. So remember, radius is halfway across the top. Diameter is the whole distance across the top, and we don't want that. It's one of the most common mistakes. So we have radius and we have height. All right, if you know those two amounts, you can calculate how much is inside of the cylinder. And the formula for volume will always be whatever the radius is, which we'll use r, squared times height, which we'll say is h, and then times the symbol pi. And remember, pi comes from all circle formulas, and every cylinder has a circle as its top and bottom. And also, we'll remember that pi is always equal to 3.14. All right, so if you have those, if you have the radius and height, you can figure out the volume of any cylinder. Let's go ahead and give one a try. And I'm just going to make up some numbers here. Let's say that this cylinder, let's say it has a radius of 4. I'm just going to draw a little 4 in here. It means the distance, maybe we'll say 4 inches. So 4 inches across the top, halfway across the top of this cylinder. And the height, let's say, is 6 inches. So this is a 6-inch tall can. Okay? And with that information, we're going to plug it right into the formula. All right, so we don't know the volume yet, but we do know that the radius we said was 4. So we'll say r is now 4. Keep the square above it. The h, the height, we know is 6. I'm going to use this little dot to show multiplication. We're going to multiply by 6. And then lastly, we're going to multiply by this pi symbol. And I'm going to leave the pi symbol as is just for now to kind of show you. Sometimes the answers are in terms of pi, meaning they actually leave the pi symbol as is. They don't convert it to the 3.14 all the time. So we're going to leave it as pi just for now. All right, now let's go ahead and do the math. Once you plug in your numbers, just follow through with the actual evaluation of the math. 4 squared, remember, is 4 times 4, or 16, times 6 times pi. And then 16 times 6 is 96. So 96 times pi. And I'm actually going to write it just like this for a moment and have you take a look. Right now, I've figured out that volume is equal to 96 pi. That would be an answer in terms of pi. And the reason I'm leaving it like that is a lot of multiple choice questions will leave this as your final answer. Sometimes you'll see it written like that. So I'm going to write down something like possible final answer. That just means that they didn't actually multiply it by 3.14. But a lot of times they do ask you to go all the way and simple, kind of, I guess they could call it an approximation answer, is that they want to know, okay, well, what is the real answer if I said pi was equal to 3.14? So 96 times 3.14 And with my calculator, I get 301.44. 301.44. And this was in inches, and it's in inches cubed because we have 3 measurements here. It's a 3-dimensional object. All right, so that would be the volume, 301.44. All right, and that's basically what we're going to be doing for each of these formulas. So let's go ahead and jump into the cone next, okay? So the cone has a formula that's very similar to the cylinder. So the cone's formula, I'm going to say, is volume equals radius squared times height times pi, exactly the same as the cylinder, except for the cone is smaller than the cylinder. In fact, it's exactly 1/3 smaller. So the last thing they like to do is actually multiply it by 1/3. So this is the formula you'll often see, 1/3 times r squared times height times pi. However, I don't really like multiplying by fractions, and I know a lot of other people don't either. So instead of multiplying by 1/3, I'm going to write divide by 3. Because multiplying by 1/3 and dividing by 3 are the exact same thing. So that's how I kind of like to write my formula, and it just makes the math a little simpler for me. Alright, so let's go ahead and plug in some numbers. And what if I use the exact same numbers before? If I say that this cone has a height of 6 and a radius halfway across of 4, let's see what the volume of this cone is. Alright, so I'm just going to go ahead and plug in the information I know. I know the radius is 4. And this is probably the trickiest part, is making sure you plug in the correct information. 4 squared times a height of 6 times pi. And in this case, I'm going to go ahead and just convert it to 3.14 right now because I want an answer that has all numbers, no pi in the answer. And don't forget, the difference between this formula is divide by 3. That's the only thing that's different. Okay, so let's do the rest of the math. 4 squared is 16 times 6 times 3.14, all divided by 3. Don't forget that. Let's keep going. 16 times 6 times 3.14, that's going to give you an answer of 301.44, which we kind of already knew from earlier. But now the last step is divide by 3, because cone is 1/3 of a cylinder. So last step, divide that answer by 3, and the volume of this cone will be 100.48. And again, whatever our unit of measurement was, if our unit of measurement was inches, we will write inches cubed. Okay? So as you see, the answer for the cone, 100, was about 1/3 of the answer for the cylinder when given the same exact measurements. A cone is always 1/3 of a cylinder with the same measurements, because that last step is just divide by 3. So cone, pretty simple, just like a cylinder. Alright, the last one and the most difficult one will be the sphere. The sphere's formula, it's a little bit like the cone. Let's go and see how it's similar and how it's different. One thing to know is that this sphere is a 3-dimensional circle. It's hard to draw a 3-dimensional circle, on a computer screen. But think of like a basketball or a baseball or some type of globe, a 3-dimensional circle. All right. So the formula for the volume that would be inside of this sphere, it's going to have r again. It's going to have a radius. And the radius of the sphere is from the inside circle to any of the outside edges. That would be your radius again. So the sphere has a radius just like the cylinder and the cone. However, it's not going to get squared this time. It's going to get cubed, meaning it's going to have r times r times r. Now, there's no height in a sphere. There's only radius. No matter which way you look, radius is the only measurement here, so we have no height in this formula. We will still have pi again, so put our pi symbol in there. And then the last part of our formula is going to be times 4/3. Yeah, another fraction. Times 4/3. All right, and this is the formula you'll often see in any formula sheet given to you on a test. 4/3 times pi times r to the third power. However, I don't like multiplying by fractions, so I'm going to change that times 4 to instead times 4 divided by 3. Because multiplying by 4/3 is the same as multiplying by 4, then dividing by 3. So I'm going to write this little formula like this. It's just, it makes more sense for me and it's easier to evaluate. Alright, so let's go ahead and plug a number in here. Let's keep it simple. Maybe we'll say the radius of this sphere is 5 inches. Okay? So given the amount of this radius of the sphere, we can now plug it into our formula. The volume will be 5 for the radius, so 5 to the third power, times our pi of 3.14, times our 4. And I always get a question like, where'd that 4 come from? It's actually in the formula. Every formula has that 4 in it for a sphere. If you don't believe me, Google it. And then divide by 3. Again, it's part of the formula. And now that I have all my numbers plugged in, we need to just do the math now. Okay, so 5 to the third power. Remember, 5 to the third power means 5 times 5 times 5, which is 125, times pi of 3.14 times 4 divided by 3. And I know it's a lot of work, but we have a calculator that can do most of this work. 125 times 3.14 times 4 is going to give us an answer of 1,570, then divided by 3. And so when you divide it by 3, we get a final answer of 523. 523. Of course, if we said the measurements were in inches, we can just say the answer is in inches cubed because we had 3 measurements. It's a 3D shape. All right, so that was our volume, 523 inches of the sphere. All right, so that is how you find the volume of any of these 3 figures. Now, the only thing that's a little bit tricky is what if instead of having to figure out the volume, you have to figure out one of the measurements of the shape, like figure out the radius or the height of something, and I'm giving you the volume. Well, let's give that one a try. We'll try it with our most difficult problem, the sphere. So I'm going to go ahead and start over, and this time I'm going to say, what if we have a sphere that instead of me telling you the radius, what if I only give you the volume? Okay, so remember the volume is the entire amount that's in the shape. So in this case, let's say the volume, let's choose, is 904.32. Okay, and what I don't know is I don't know the radius. Let's try to use some kind of backwards math or inverse operation to figure out what is the radius. And remember, the radius is the distance from the center to the outside of any of the outsides. So it doesn't really matter where I draw the radius. Okay, so what is the radius? All right. Let's go ahead and use our formula. So what we're going to do here is we're going to use our formula exactly the same way we did before, but it's going to kind of feel like it works backwards a little bit. So the formula was volume is equal to r third times pi times 4 divided by 3. Okay, now let's plug in what we know. We don't know the radius this time like we did in the last problem. We only know the volume. So I'm going to plug in the volume is 904.32. I do not know what this R is, so I'll leave it as R. I actually do know what pi is, so let's go ahead and say times 3.14. I do know that. And of course the 4 is still 4. And the divide by 3 stays as well. So now I have a nice step here where I substituted in the values I know. Okay, so let's try to use our math skills to solve for R. We're going to solve for a variable just like we solve for all variables. First, try to simplify this problem as the best you can. Okay, so let's see, maybe this 3.14 times 4, I could simplify that. Or I can just jump right into inverse operation if I wanted to. So you know what, I'm actually just going to jump right into inverse operation because that's usually what I do for solving. So let's go ahead and do the opposite operation of this divide by 3. Remember, when doing inverse operation, you want to kind of work the problem backwards. And if we look down here, the last thing we did was divide by 3. So the first thing we'll do is the opposite of divide by 3, which is multiply by 3. So I'm actually going to multiply both sides of this problem by 3. The inverse operation is going to be multiply by 3. Because if I multiply the right-hand side of the problem by 3, it will eliminate that divide by 3 step. And on the left-hand side of the problem, well, I'll just have to do a little bit of math. 3 times 904 is going to make 2,712.96. All right, now the rest of the problem I have is r cubed times 3.14 times 4. Okay. All right, let's keep going. Let's see. Now this 3.14 times 4, that's just kind of glaring out to me. That's begging to be multiplied. So I'm going to go ahead and multiply 3.14 times 4. When I do that, it comes out to 12.56. So I'm just going to simplify this problem by multiplying the 3.14 times the 4. The rest of the problem I have not really changed at all. I'm just rewriting it. So that's a little simpler, simplified. Okay, so this is what I'm left with. 2712.96 equals r cubed times 12.56. Well, what's the inverse operation of multiplying? It's dividing. So in order to get rid of this step, we're going to divide both sides by 12.56. Let's divide everything by 12.56. Remember, divide both sides by that inverse operation. Okay? Let's see what that gets us. When I take the 2712.96 and I divide it by the 12.56, I get 216. And on the right-hand side, well, this all cancels out because multiplying and dividing are inverse steps. So now I have 216 equals, the only thing left, r to the third power. We're almost there. The last thing we're going to do here is try to figure out, well, the answer is not 216. R cubed is 216. So in order to figure out what r is, we have to do the opposite of cubing. The opposite of cubing is actually called cube rooting, cube root. It's kind of like a square root symbol that we saw in the other problems, but instead it's going to have a little 3 right here showing that it's a cube root, not a square root. So what number times itself 3 times will give us 216. We're going to need a calculator for that. If we pull up inside of our Performance Matters, there is a little calculator button up here. So I'm going to open the calculator and then not the square root symbol, but instead go over here to the far right and you'll see this little square root symbol with looks like a Y above it. I'm going to click that button and then it says, okay, what kind of root do you want to do? I'm going to do a cube root with a 3 and then put the number, click right here to put the number inside of it. What do we say, 216? The cube root of 216, and the answer is 6. Turns out 6 is going to be the answer for cube root of 216. So let's go back to our problem, and we've now figured out that the cube root of 216 is 6. That means that 6 is our radius, so we figured it out that back in our original problem, this radius is 6. And of course, you can always check it by plugging 6 back into the original formula and see if you get the volume of 904.32. So to recap, the formulas are used to find volume by plugging in the information you know, or you can use the formula in inverse operation to even figure out pieces of the figure if you know the volume. Okay. Of course, you're going to see some problems that have real-life applications where they're giving you real-life objects, not just these little pictures. So just read the problem and figure out which formula you should be using. All right, well, if you have any questions, put them in the comments, and I'll see you later. Now for a word from our sponsor, Papercut Games. This week's game, Apples to Apples. This is a party game that I know a lot of people really love. So in Apples to Apples, it's a social game where each player is going to get a bunch of these red cards, and they just have different things on them that are kind of random, like poodles or stub toes or Bigfoot. And then in the middle, you're going to draw one of these green cards that has usually like an adjective or something on it, like meek or masculine or delicious. All right, so let's say we pull delicious. Now, every person is then going to look at their own cards and put down a card that they think matches with delicious or they think is funny. And then one person gets to judge. So the fun part is that you got to think, what do you think the judge is going to play or is going to choose as the best one? So let's say we have 5 people and they all put down one of their red cards where they think is delicious, and then the judge reads them all out, and then you see which one's the funniest, and the judge gets to choose. So for delicious, it could be spilled milk. That's kind of gross, but maybe that's funny. It could be Swiss cheese. Swiss cheese could be the winner. Delicious could be Thanksgiving Day. I know that's delicious. It could be bald eagles. Alright, that's a little weird, but maybe that's the one you think is funny. Or body odor. That's just gross. And some people like to play cards that just make everyone laugh, or they try to match. And if I were choosing this, I would say that the most delicious one would be Thanksgiving Day. Of course, I love Thanksgiving. But you as a judge would get to pick your own winner, and then whoever wins gets the green card, and you play whenever you feel like stop playing. Usually you can play to like whoever gets 5 green cards wins the game or something like that. But it's a very fun game. You can play with family, friends, anyone. Go get Apples to Apples. And this is Mr. Bigsby, and I approve this message.